This is the fourth experiment of image classification by using VGG or RESNET. The first we will import the libraries. The libraries are TensorFlow, import pathlib. This pathlib will stand for Python library module for file system path. First we will download and prepare the data set. Sets the URL of a zip file that contains a small cats versus dogs data set, and then downloads the file from the origin to cache directory. It will names it as cats and dogs filtered.zip and extract automatically unzips it. It returns the path of the downloaded file, and then it will pathlib.path. It will give the directory containing the downloaded zip, and then it will append to the directory path to form the path to the extracted dataset folder. And then we will set the training directory and validation directory to the subfolders that contains training and validation images respectively. And then image size we have given here 224 to 224. When it defines the target height and width for images, this size matches typically ImageNet to pre-trained models as RESNET or VGG. And then batch size sets how many images the data set yields per batch. Train data set raw, it will image arranged in subdirectories. Then train directory is the root directory containing the class subfolders. Image size reaches each loaded image to 224 and 224. Then batch sets will return the batches of 32 images. And where images is a batch tensor and labels are integer class indices. And validation part same as above, but for the validation set val ds raw yields validation batches. And then function 2 build and train model will define the function train model, which takes module name used for printing and the pre-source function appropriate to the base. Then it will prints a header, so you know which model is being trained when you call the function. In here pre-processed data, it will apply the map to raw data set to pre-process images with pre-process function. Typically it performs the correct scaling or normalization expecting the pre-trained model, and then it will prefetches the overlap prefetches the overlap and then and model execution while the model trains one batch. The input pipeline prepares the next batch and will load the base model as model using the provided base model RESNET50 or VGG16, and then it will loads weights pre-trained on ImageNet and excludes the final classification head. Then a base model dot trainable it will be false because its weights will not be updated during training. This is standard transfer learning practices for first training stage. And classification head adds a global average pooling 2D layer applied to the base model output feature maps, and then adds a dense fully connected layer with 122 units and ReLU activation to learn combinations of the pooled features. Then it will add the final classification layers with 2 units as cats versus dogs by using softmax activation, which output class probability is summing to 1. And will compile the model with adaptive optimizer that generally works with out of the box. Loss for appropriate when labels are integer classification 0 to 1. And then we'll train the model, starts training on the prepared with validation. Epochs has 3. Number of full passes over the training data, and prints a progress for per epoch metrics. And will train RESNET50. It will calls to train a model using RESNET as the base, named printed for clarity, and it will pre-process function that applies normal as expected by RESNET50, and will train VGG next separately. Same as above, but uses VGG16 as the base model. It will uses the VGG16 pre-process input, which performs VGG specific pre-processing, and will comparison between VGG and RESNET50. It will create a grid with one row and two columns and activates the first subplot. Then it will training accuracy per epoch for RESNET50 and validation accuracy per epoch for RESNET50, training accuracy for epoch for VGG16, validation accuracy per epoch for VGG16. So thank you. This was the fourth experiment.